All right, so quick intro to similar shapes. All right. First, we've been talking about transformations and how transformations affect shapes on a coordinate grid. Well, when we do rigid transformations, there's three types: translations, reflections, and rotations. We've talked about them a lot. We get congruent shapes. All right, so exactly the same. Angles are corresponding angles are congruent, and all the corresponding side lengths are exactly equal to each other. So translations are slides, reflections are flips, and rotations are spins. And that just keeps the same shape, just puts it in a different position. All right, now what we're going to talk about now is adding in a dilation and what happens when we add in a dilation. So we can use any of the rigid transformations, these three up here. And once we add in a dilation, that enlarges or reduces, shrinks or enlarges the shape. And we get, instead of congruent shapes exactly the same, we get copies that are smaller or larger than the original. And these shapes are called similar. All right? So they look the same, they're just different sizes. Now, there's two things that are true about them. One's kind of, I don't know, surprising maybe to some people. You think that everything grows, but actually the angles all stay the same. So corresponding angles are still congruent. The other part is that instead of corresponding side lengths being equal, now corresponding side lengths are proportional. Proportional means that they have equal ratios. So what we're going to do is we're going to look at one shape and we're going to see how transformations could help us decide if these shapes are similar. So I'm going to draw this one in here. All right, that is a terrible triangle. Let's try that again. Down, over, and let me try this hypotenuse here. Sorry, what do I have to do? Okay, if we call this A, B, and C, we can see that these two triangles look very similar. In fact, I've already drawn in that this angle here looks about the same as that angle there. I put two hash marks here, or two arc lines there, two arc lines here to show that they correspond, and then we have our right angle C and our right angle F. If we were to put them on top of each other, let me try this. Okay, if I move that, you see that angle's the same, that angle's the same, and that angle's the same. So, oops. So, right, that checks off that first part up here. That corresponding angles are congruent. So the second thing we have to just show is that corresponding side lengths are proportional. And what we'll do here is I'll change up the color. I'll go with this color here. And okay, what side corresponds with that? Well, this side corresponds with that. We are going to compare their side lengths and put it into a ratio or fraction. So the side length of 2 here corresponds with the side length of 4 here. We want to see if that ratio is equal to the ratio of other corresponding side lengths. So we're going to go, let's pick this pretty blue color here, and we're going to go CB. What side length is corresponding to that? That would be FE. So we'll count up the blocks, 1, 2, 3, and that compares to 1, 2, 3, 4, 5, 6. So we have 3 and 6, and all we have to do is check to see if these two ratios are equal. If they are, they form a proportion, and these two shapes are therefore similar. All right, so if we check these, 2/4 and 3/6 both equal a half, so they are equal. Another way to check on ones that aren't this simple is to do our cross products. If fractions are equal, they'll have equal cross products. So 6 times 2 is 12, 4 times 3 is 12, so therefore these are equal. All right, so if corresponding side lengths are proportional and corresponding angles are congruent, we have similar shapes. So similar shapes are shapes that look the same but are different sizes, and they have to fit these two things. All right, so that's how to check it. And then if I were trying to describe how I know these two are similar, I would say that because often in the con examples and in your textbook, they're going to ask you to explain how to use transformations to map. Mapping is a big word that they use a lot. To map the smaller shape onto the larger, or sometimes they say the larger onto the smaller, or sometimes they indicate in different ways. But what we're doing is we have to describe in transformations how to map one shape onto the other. So we'll go from smaller to large, small to large. So what I would describe it as is first, do a dilation with a scale factor of 2 around point C. Didn't want to do that. Let's go and reverse that. There we go. Around point C. So dilate around point C. So a scale factor of 2. So dilation. So I'm describing how to map the smaller onto the larger using transformations. Dilation, scale factor 2 from point C. So that means everything's going to enlarge from point C, and C is just going to stay where it is. All right. So if I enlarge this line by a scale factor of 2, instead of 2, it's going to be 4. So A would be out here now. And if I were to take B away from C, I'm going to double the distance it is from that center of dilation. So it's going to come out to here. And I have this now. So that's my first transformation, but I haven't put it perfectly on top of the other shape, so I'm going to do a second transformation. Now, what could get the new dilated ABC, or maybe A prime, B prime, C prime, okay, to fit perfectly on top? Well, hopefully you said a translation. Translation. And in what direction? I think we need to move it right. And how many spaces? Well, we have to get that point all the way over to its corresponding point. So that's 1, 2, 3, 4, 5, 6 spots. So translation right 6. All right. And let's see if I can get all these points to work together nicely. And oh no, I didn't get the big line there. Let me try again. Let me try this guy again. Let's try that. Oh yeah. All right. I moved the F with it too, and then we map it right on top, and it should be perfect. My that point's a little bit off, but just anyway. So those two translations map it on to its similar shape, and so yeah, so that's our intro. So big things are the rigid transformations. These three here create congruent shapes, and as soon as you add in a dilation, you get similar shapes. And similar shapes have to have two things. You have to have corresponding angles that are congruent and corresponding side lengths that are proportional. We showed how to check if corresponding side lengths were proportional. And also we described how to use transformations to map one figure onto another figure to prove that it is in fact similar. All right, there it is for today. Hope you enjoyed this amazing math lesson.